So we were able to make a bolt, we were able to make a spring, but did you know that there's a few other ways to define helixes in Alibre? And I came across this interesting looking lamp the other day. How hard would that be to model in Alibre? Might be easier than you think. So in the modeling environment, let's go ahead and sketch on the XY plane. And let's make a circle. Now I'm going to choose horizontal between the circle center and the origin, and also choose a diameter on the circle. Let's go with something like 0.5. From here, we'll take the circle, we'll make it about 2 away from the origin and deactivate. From here, I'll choose Helix, and I can choose my axis, and I've produced a helix. Now we've talked through a few ways that we can customize the ends using advanced features, but there are some other helical features that are pretty impressive as well. Let's go with counterclockwise, right? So we can change from clockwise to counterclockwise. I can also reverse the direction of my helix. Now I'm defining by height and pitch. That's my personal way of defining a helix. But I can also choose height and revolution. And what this does is it allows me to say I want a 10-inch high helix, and I want that with 4.5 revolutions exactly. With certain needs, you may need to define revolutions instead of pitch, and that makes it a lot easier than trying to do the math to convert what kinds of revolutions you might need off of a pitch. You also can define this by revolution and pitch, so I can say I want a pitch of 2, and I want exactly 5.25 revolutions, and so on. And Alibre can figure that out for you. So there are 3 ways to define helixes down here. Again, I tend to like height and pitch. So I'll give this a height of 10. I'll give this a pitch of 2. That's fine. Now we talked about having a flat section in the last video with a transitional area. But what if we want the entire helix to be in a state of transition? Well, Alibre gives us the tools to be able to do that. I can change my pitch type here from constant to variable ratio. I'll go ahead and give this a height of 20 just to make things a little bit more visible. And let's say I want a ratio of 5, right? So I want to start at a pitch of 2, but I want it to constantly grow at a ratio of 5. Well, I can certainly do that. And there we can see we're already starting to look like that lamp, and we grow taller and taller and taller as the helix goes on. I think that's a very useful feature. We can also, amongst all of this, add a taper. I can maybe give this a 10-degree taper if we want it to grow in our diameter as well as we grow in our pitch simultaneously. But that's not the only option available to us. I can also say variable end. Notice I have an error here that the sweep results in a self-intersecting surface. That's because my end is too tight of a pitch. If I make this 1 or greater, then that will fix the error. So in this case, I'm starting with a pitch of 2 where my sketch is, and at the end of my helix, I can have a pitch of 1 inch. I can make that a pitch of 10 inches if I wish, or anywhere else. So not only can I grow at a constant factor, I also have the luxury of being able to define my start and end pitches and have the helix smoothly transition between the two. This looks like it will be a fine lamp for my needs. So I'll go ahead and say OK here. I'll sketch on this plane. I'll make a center rectangle. And I'll go with something like 8 by 5 looks good. Make sure that one of our lines is horizontal. We'll deactivate and extrude. I'll choose mid-plane, and I'll go with 1. So I've got this lamp that sort of grows out of its base, and then I'll imagine I'll put a little light bulb on the end there or something like that to make it kind of fun. But that should cover many options with helical features. But there are other options as well. We can do spirals, and let's take a look at that in the next video.